3, 2. Put your phone away.
Oh,
Okay. So we have the X-ray circuitry. That's Joy, that's Christina, and I'm Chris. So this is the model that we went off of to make our physical model of the circuitry. Looks great, fantabulous. Alright, so I have specifically the primary circuit. So we have the main power switch, which provides energy to the whole circuit. We have the circuit breaker, which protects itself from itself. And if there was no circuit breaker, it would be a lot more vulnerable to overloads and short circuits. The auto transformer increases the voltage to what the radiographer sets it on the KVP selector on the control panel. And then the KVP meter is just reading the KVP to make sure that it's set to what it needs to be. We have the exposure timer, which is kind of the same thing, but instead of the KVP, it's just making sure that it's doing the exact time that they set on the panel. There's the step-up transformer primary. On my side, it has less coils than the secondary side, so that it can step up the KV and lower the mass. And then we have the line compensator, which will just stabilize the voltage at about 220 volts.
you wanna point them out on the diagram here?
Yeah. Alright, so on the diagram here, this is where the main power source comes in. The circuit breaker is this little piece of cardboard right here. The auto transformer is gonna be right here. And then we have this should be the KVP meter. This should be the time. That's the line compensator right here. And then the major, yep, right here. And then Christina,
Okay.
this is it here.
So I have the secondary circuit. So it consists of the step-up transformer, the MA meter, the rectification circuit, and the tube. So the step-up transformer, also known as the high voltage transformer, it increases the voltage and lowers the amperage. The primary voltage is measured in volts and the secondary in kilovolts. The primary current in the primary current in amperes and secondary in milliamps. So that's the step-up transformer. And of course, like you said, it has less coils on the primary side and more coils on the secondary side. The MA meter measures the current in milliamps flowing through the X-ray tube during an exposure. The rectification circuit, it converts the AC to DC, which is required for the tube to function. The rectification is achieved using the diodes, which these are the little diodes right here, and this is the rectification circuit. This is the, step-up transformer, thank you. My mind drew a blank. This makes the current flow in one direction when it transfers from AC to DC. Without this circuit, or if it malfunctions, the tube wouldn't function properly. So if it doesn't transfer it to DC, then that means that the current is not flowing in one direction, and that would basically explode the tube and make it malfunction. And then we have the tube, which is over here. The tube converts electrical energy into X-ray photons by accelerating the electrons from the cathode to the anode. The tube contains an evacuated glass or metal containing a cathode, which is the negative side of the tube, and an anode, which is the positive side of the tube. When the prep button is pushed after technical factors are selected, the filament heats up and emits electrons through thermiotic emission. The high voltage potential difference between the cathode and the target accelerates those electrons toward the target. When they collide with the target, they lose energy, which is released in the form of X-rays. I also put for the rectification circuit, if that malfunctions, oh, I already said that. Never mind. Okay.
I have the filament circuit. Yes, okay. So in the filament circuit, you have the rheostat, probably saying that wrong, and the step-down transformer. So for the rheostat, it's also known as the MA selector. The rheostat is controlled by the MA selector on the operating console, which directly determines the current that is applied to the selected filament and the number of electrons boiled off and available for X-ray production. For the step-down transformer, it uses a process called mutual induction to increase the current by reducing the voltage and increasing the MA. Once the current is increased, it heats the filament chosen by the operator and begins boiling off electrons. The time selected on the console or at the console is the amount of time the current is flowing through the X-ray tube. So, this is my step-down transformer. This is my little rheostat. Isn't she cute? And then once everything is increased here, it flows to the X-ray tube and it heats up the filament and starts the whole boiling process, thermionic emission. If the rheostat malfunctions, it could cause a disruption in current control or even circuit damage if the resistance comes too high or too low. If the step-down transformer defects, it could cause the X-ray tube to not receive any necessary voltage to heat up electrons, which would lead to no X-rays. Yeah, that's it. That's the X-rays.